Now we're going to look at dividing complex numbers, but we need to start out with noticing what happens when we multiply complex conjugates together. When we multiply a plus bi times a minus bi, we end up with a squared plus b squared. So usually if we multiplied a plus b times a minus b, we would end up with a squared minus b squared. But because we have the I over here, that gives us, if we put an I in there, now we would have negative bi squared, which is going to make this turn into a negative 1, which is going to get multiplied by that negative and make it positive. It makes it into this. That is exactly what happened on this problem. We ended up with 36 plus 25, and that got rid of the imaginary term. That's why we ended up with 0i. We're going to use this fact to help us when we are trying to divide complex numbers. So, and what we're noticing is that the product of a complex number and its conjugate is always a real number. There is 0 for the imaginary part. So that's the key to what they're showing you, is the imaginary part went away. When you multiply two complex conjugates together, the imaginary part goes away and you end up with a real number. That's going to help us when we're dividing complex numbers. So to find the quotient of two complex numbers in standard form, we're going to multiply both the numerator and the denominator by the conjugate of the by the complex conjugate, left that part out, by the complex conjugate of the denominator. Okay, so let's find each quotient. So let's make sure we remember what conjugates are. It means that it is a binomial that has the opposite sign, looks the same as the other one, but has the opposite sign. So the conjugate of 5 minus I would be 5 plus I. So we're going to multiply this fraction by 5 plus I over 5 plus I. That makes this equal to 1. Okay, I'm multiplying by a fraction that is equivalent to 1. It is what we call a funny looking one, right? We're doing the multiply by a funny looking 1 trick. So I've got to multiply the numerators, and so 3 times 5 is going to give me 15, and then 3 times the I is going to give me plus 3i, 2i times 5 is plus 10i, and 2i times I is plus 2i squared. That I squared is going to turn into a negative 1 here in a minute. In my denominator, I'm going to have 5 squared, which is 25, plus I squared, which is just going to, it's going to be minus I squared, which is going to end up being plus 1. But let me go ahead and write it as minus I squared so that you can realize, remember, that turns into a negative 1. So we'll simplify the numerator. It's going to be 15. I'm going to show this extra step. You probably could skip to the last one, but just want to show it to make sure you're clear. 15 plus 13i, and then the plus 2 times negative 1 would be over 25 minus 1 times negative 1. Okay, you could probably skip from here to here and just combine 15 and a negative 2, which is what I'm about to do down here, 13, and then add your 3i and your 10i, giving you 13i. And then you can say, well, this is going to be 25 plus 1, which is 26. Since I have a fraction with only one term in the denominator, I will split that into two separate fractions. You probably could have mentally canceled and turned both of those into 1/2. So you probably could have gone from here to 13 over 26 is 1/2, plus 13 over 26i, which is 1/2 I. Do notice that I have to write this like this. I can't leave it like that. That is not in standard form of a plus bi. I had to go all the way to put it in standard form, and the I belongs after the fraction, not in the numerator of that fraction. When I come around to part B, I only have one term in the denominator. So this is like having 0 plus I. So just multiply by negative I over negative I. that would be multiplying by the conjugate. It'll give you negative 3i over negative I getting squared, and negative I squared turns into a positive 1, negative 3i over 1. So we're going to end up with negative 3i, but this is not standard form. So we're going to have to rewrite that as not standard form. So we will have to rewrite that as 0 minus 3i. And now we have put it into standard form. We will hold off for this part until we get into class on the next day. Although I did already go over this with you earlier, I'll go over it again when I'm in person.